on behalf of medicine. So please continue.
Madam, first of all, thank you for your introduction. And I also thank the organizers for giving me an opportunity to present recent advances in post-harvest fisheries engineering in this national reference course on current developments in veterinary and fishery sciences. Thank you once again. I hope I am audible.
Yes, sir, you are audible.
Yeah. To start with, let me once again introduce myself. Myself, Dr. Murali S. I am working as a scientist at Central Institute of Fisheries Technology, Kochi, under the engineering section. I am basically an agricultural engineer. I did my BTech from Tamil Nadu Agricultural University. Then I done my master's and PhD from IAR in New Delhi, where I got specialized in post-harvest technology. And I am first posted at CAFD, that is Central Institute of Fisheries Technology, in 2016. From then I am continuing here. And my major activities are, I will be adding a slides, but before that, most of my activities are the engineering interventions in the post-harvest fisheries sector. Once the fish is harvested, what are the engineering interventions that can be there? So those are the areas where I am working, and my team also working on that area. To start with, let me introduce my institution. That is ICR, Central Institute of Fisheries Technology, Cochin. The institute caters to harvest and post-harvest operations since 1957. We have a headquarters at Cochin, and we do have a research centers at 3 places. One is Visakhapatnam, Andhra Pradesh, Veraval, Gujarat, and Mumbai. And our institution is a ISO 9000-2015 certified organization. And we do have a NABL accredited referral lab. Also, we have a NABL accredited reference lab for fish and fishery products. So, of course, the title is on recent developments in post-harvest fisheries engineering. I am going to discuss or talk about the areas where we are working, our developments. Here, the major areas are, one is developing equipments, the implements for assisting the fish processing operations. Then developing non-destructive sensors in evaluating fish quality and freshness. We do also work on energy and water optimization techniques for the seafood industries. We also work on future refrigeration systems using natural refrigerants. And all these research areas, how we take these researches to the field, to the ultimate stakeholders, users. That is through entrepreneurship development. So that aspect also I will be covering at the end. And I am going one by one slides. If any of you participants are having any difficulty or any clarification you require, you can stop me, no problem. And I hope that I am allotted a time of 1 hour from now. So I may take some 40 minutes or 45 minutes. Then if anything is there also, we can discuss. Or in between, if you have any doubt also, you can stop me. To start with, actually, as I already told you, we are also working on developing equipments, especially the dryers for preparation of dry fishes or any other products to be dried. We have different types of dryers. To introduce that, I would like to give you brief information about the dry fish status. About 70% of the total catch of fish that is going for drying purpose. Either it is meant for export or it is for the local consumption. The dried products, especially the marine fishes, are transported to inland areas as well for domestic consumption. And I would like to just mention that there is the largest dry fish market, which is located in Assam. That is called Jagiro Dry Fish Market. And there is a huge scope for the dry fish to be can be a bigger contributor to our total fish export. A study conducted about a decade back says that the dry fish in the total fish export contributes 8%. because the products are not appropriately dried or stored or packed. You can see the photographs on the right side, how the dry fishes are stored in gunny bags, bamboo baskets, or in open. So the studies by MPDA, that is Marine Product Export and Development Authority, says about 8% only there. Now, APIDA also says if it is appropriately packed, especially when you go for modified atmospheric packaging, the dry fish percentage in the total fish export can be improved to 25%. And as usual, everybody knows what is the importance of dry fish. It is a cheap source of nutrition. It's a high protein source. Dry fish is available throughout the year. As and when you have issues with them, especially for the fishers, when they bring the fish to the shore, there will be perishability issues and price variations. When it is converted into dry fish, it can be kept throughout the year, and the price issues also can be solved. And it also acts as a source of rural livelihood and income, especially when the times of pandemic and lockdown. This will supplement the fresh fish requirements. So fish drying generally, I hope everybody knows that it is done in the open, especially on the roadsides, beaches. And there is a study which says that about 30 to 40% of the fish that kept for drying, open sun drying, can be lost. But the advantages are the energy is free, renewable, abundant, and it's a cheap method. So what is the alternative? One such alternative, which is, of course, not very cheap, but it is affordable for the fishers or the farmers, that is solar dryers. So what is meant by solar drying? You enhance the effect of solar radiation using some structures, small structures, so that we can generate high temperature, reduce the relative humidity. Thus, you can improve the drying efficiency, or you can bring down the moisture of the fish to the very lowest level, required level. And also it takes lesser time compared to open sun drying. In terms of quality, you will get tasty, color and nutritive value will be there. And again, it is environmental friendly and economically viable. The drawbacks are, again, you cannot use these solar dryers during rainy period or cloudy days. And again, it is not available during night time. So what is the alternative? The solar dryer has to be supplemented with a backup systems. So as I already mentioned, solar dryer, you can see a picture on the right side. There is a part called solar collector. That is a portion where the solar radiation is concentrated and sent to the drying chamber. There are three parts. One is solar collector, drying chamber, and the airflow mechanism, inlet and outlet. The collector is basically a box where the top side is glass, bottom may be aluminum frames, or sometimes puff insulated chamber. There will be opening. So fresh air will go into it. The air will get heated up because of the incoming solar radiation. Then the temperature of the air will be increased to about 60 degrees Celsius. Then it will go to the drying chamber where you place the material for drying, and the moisture will be removed, and then moisture will go from the top. So as I already told you, there are three portions, and there are different types of dryers. Direct method, indirect method, mixed and hybrid method. Direct method means you will directly expose your product just below the glass. You can see a picture on the top where the products are kept just below the cover. The second picture you can see, the product is kept in a separate chamber. That is called indirect method. When you say mixed method, you can keep in both the places, in the chamber as well as in the collector. Both the places the material can be kept. When we say hybrid, we have to have a backup systems. For example, temperature you are not attaining from the solar system. You can go for electrical heating element, which will supplement the requirements. And the classification of dryers, there are different types, different variations based on the type of airflow, the type of the heat storage materials being used, then the type of construction materials, so that I am not going into the detail. So the dryer which we are developing here are multi-purpose in nature. Of course, it is meant for fish. It can also be used for drying any agricultural commodities, including fruits, vegetables, spices. So I would like to introduce our dryers, solar hybrid dryers, one by one. The first one is solar dryer with electrical backup, 20 kg capacity. where you can see the picture, top picture. There is a frame and then there is a top roof. That is the solar collector. The top layer is a glass, below is the aluminum frame. There is a opening in the right side so that the fresh air will go inside, get heated up. Then the heated air will come down. We have a provision there. There is a blower down, which will pull the hot air from top and then throw it to your drying chamber, where we have a sensor which senses what is the temperature of the incoming air. If the air is having sufficient temperature, it will directly go. If not, if it is, for example, you set a temperature of 60 degrees Celsius and the incoming temperature is 40, the 20 degrees Celsius difference will be met from the heating coil, which will automatically switch on. So that's how this 20 kg dryer works. Similarly, we have a 40 kg dryer. Then we have a 60 kg dryer here. Here, the principle is same. You can see the picture on the left side top. That is the solar collector, but here it is a water collector. So what we do, we will send a water to the top. Water will stay on the collector. During the sunshine hours, the water will get heated up. The heated water will come and there is a tank. You can see the schematics also. The blue color and red one, that is a water tank. Blue is the cold water, red is the hot water. So the blue water, the cold water go to the top, get heated up and come as a hot water. That hot water is again sent to the heat exchangers, which is placed in the drying section, drying chamber. So indirectly heat will be drawn for drying. So here, what is the difference between the previous two dryers and this dryer? There we are using air collectors. That means fresh air will go inside. Here water will go. The advantage is that when you have a very high temperature, say now your place Rajasthan, now very high sunshine will be there, and most of the throughout the year you will get sunshine. So there, when you get more than sufficient heat, when aerating is happening, if it is 60 you want, but the temperature incoming is 70 degrees Celsius, you doesn't want it. What to do? But here it's a water collector. The temperature of the water can be increased to any number. For example, 60, 70, 80 or 90 degree, 100 degrees Celsius. Then that hot water will be stored. This hot water will be used for drying purpose. Suppose now it is a sunshine. It is sunset. Suppose if it is 6 o'clock, there is no more sun. So during that time, the hot water which is already stored because of the additional sunshine or the sufficient heat we got in the morning, which can be used. So what I can do here, even after the sunset, sunshine is over, I can use the dryer for another 1 or 2 hours. Whereas in air collectors, if the sunset, there is no sunshine, immediately heat will go. So there won't be any heat for drying purpose. So that is the advantage here. Here the backup is a LPG backup, just like the LPG cylinder, which this is used in the kitchen. Just like that, there will be LPG cylinder, which will heat the water in the tank. For example, it's a rainy season. No heat is, no water can be heated. So through the LPG, the water will be heated. The heated water will go to the heat exchanger and then dryer will function. This is also entirely automated. We are not doing anything manually, only switching on the dryer. All the things are regulated with the help of temperature sensors and the PLCs. So there is one more dryer, a cheap dryer, that is solar tunnel dryer. Here we are trying to use the solar radiation directly passing through the sheets. It is basically a polythene sheet having a UV stabilized polythene sheet of about 200 micron thickness. This can be even, this is basically a temporary structure. You can see the picture here. We are using wood material for that frames and other things. However, the food contact areas are SS mesh. Then the polythene sheet and PVC pipes are used. Whereas if somebody is requiring a permanent structure, you can see this picture. Here, we can go for polycarbonate sheet with aluminum frames, with flooring, with a tiles flooring. And the entire system can be connected to your PV, solar PV. So that this type of dryers also available with us. And this, all these dryers are multi-purpose. As you can see from the picture, the coconut copras also being dried here. Or if you have a trace, we can keep any material and then it can be dried. Then we do have a biomass dryer. Here no solar is involved. The wood materials, whatever dried wood materials can be fed into the biomass furnace, the second feature. Then it has to be fired and closed. Then heat will be coming to the drying chamber, which you are seeing from the first photograph. The hot air will come from down. There are trays there. The hot air will move through the trays and go out. The trays are where we kept the material for drying. These dryers are mostly used for carbon drying. But it can also be used for any material. It is also multi-purpose in nature. Then we do have an household dryer, electrical dryer, which can be kept inside the house. Then the advanced drying technology, if you say, we have a IR dryer, infrared dryer. Infrared dryer means we have a infrared bulbs where this bulb will generate the radiation in the infrared region. You know, there is a electromagnetic spectrum where there is a visible range. So when the visible range is VGR, after R, there is infrared. This is a non-ionizing radiation. You can see the spectrum. Left side, whatever you are seeing, ultraviolet, X-rays or gamma rays are harmful, which are ionizing in nature, which can create a byproduct in your body if it is exposed. Whereas infrared, microwaves and radio waves are non-ionizing radiations, no issues. So these infrared bulbs are being used in medicinal field also. So here, when the bulbs are switched on, it generates a wavelength, this particular radiation wavelength. The wavelength carries an energy called photons, which moves through and attack your food particle. Here, one difference between the earlier dryers, it can be an electrical dryer or solar dryer or any dryer. Here, the advantage is that the dry heat of the food material, heating of the food material occurs instantaneously because the radiation, you know, it is non-ionizing radiation which moves through the product. So immediately the food particles are getting heated up. Also, the water particles in the food also getting heated up. Whereas in the other conventional dryers, hot air only going. The hot air has to slowly move from the outer surface of the food to the inside. Suppose you have a product with more thickness, more time it will take. So slowly the heat will go from top to the core area. That is the thermal point or the cold point. It has to reach. Here, simultaneously, instantaneously, the entire food product will be heated up. So immediately the water will come to the surface. Then through a fan mechanism, the water will be removed from the product. So what are the advantages? Short drying time. You no need to wait for example, a solar dryer for fish drying takes about 8 to 10 hours. Here your drying can be completed within 2 to 3 hours. One advantage. Secondly, you are not drying for prolonged period. So the color changes occurring on the food surface is very, very limited. So you can retain the color, flavor, texture, and the taste. So these are the advantages with this. But what are the drawbacks? As a batch type dryer, when you compare this infrared dryer with a mechanical electrical dryer, here the maintenance cost will be more because the bulbs are prone to spoil. And also the initial investment will be slightly higher than the electrical dryers. So what we have done, we had a project here at CAFT and funded by Ministry of Food Processing Industries, where one of my colleagues has developed a conveyor type IR dryer. Here, from one end you place the material so that it will go from one end and then it will come back in the second conveyor and then the material will be dried and then received. So this is a prototype. Then we do have a pilot scale dryer, similar setup. It's not shown here. There we have 4 conveyor belts. So from one layer you feed it, it will move in one by one layer, and then 4th layer it will come as a dried product. So here within 2 hours you will get the dried prawns or dried fish, or for that matter any product can be dried. Here instead of the bulbs, because bulbs having a it's prone to breakage, so we are using here ceramic heaters, which also generates the radiation in the infrared region. So here with this we can get the shorter drying time, high quality product. However, as I already mentioned, the cost, initial investment will be more. So advantages, as I already told you, that you can see the convective heating, no, that initially I referred. The heat goes to the product from outer to inside, you can see. But here infrared heating, it is simultaneous heating and uniform heating. You see all temperature, no, 22 means all 22 degrees Celsius. Whereas in the product, you can see 18 degree, 20 degree, 26 like that, there will be variation. So shorter process time, improved energy efficiency, uniform product temperature, superior quality, high degree of process control. Space can be saved, eco-friendly, intermittent energy source. It can also be attached with, the hotter resistance. It can also be integrated with conductive type of dryers, vibration, freeze dryers, vacuum and microwave technologies. Another dryer also we have, that is auto-assisted microwave drying system. Here we are using a microwave energy. You must have also aware microwave oven. Similar technology, microwave dryers are there. Here again, just like a auto-assisted higher dryer, we do have a auto-assisted microwave dryer where the product will be sent from one end to the another end. And the principle of drying will be different from the IR dryer. Here, when the microwave is passed to the product, due to the dipolar rotation, the heat will be generated. The molecules of food will get heat, generated, vibrational. Then, due to that, there will be friction and the heat will be generated. Because of that heat, the product will heated up. The water particles will get vaporized and come to the surface. So these are the dryers I explained, but we should also know how the costing and energy analysis. So a solar dryer only, the comparison is given here. If you take a solar electrical hybrid dryer of 20 kg capacity and you take a electrical dryer of 20 kg, you could have a savings of, in terms of kilowatt hour, you can see at least half of the savings in terms of electricity charge, it can be reduced if you go with solar systems. It is applicable for all the solar based drying systems. And you can also see the operational cost, rupees 2.9 per kg of fish in the 20 kg dryer. In the 40 kg dryer, it is 2.15, LPG dryer 3.1. So in addition to the dryers, we also develop on some gadgets, applications, IoT, AI based gadgets. Here I am talking about an automatic data acquisition and alert system to the dryer users. Here, the different types of solar dryers are there. A person who is actually doing some research, some experiments on the dryers knows that we have to take a weight of the samples in a set intervals. And every time you open a dryer, the heat will go out. Then again, it will take some more time for the dryer to generate that particular heat and maintain it. So we have developed a system. Remotely, you get the information on the material drying status. For example, what is the weight of the fish when we keep it for drying? What is the weight of the fish once half an hour or 1 hour? What is the moisture of the product, present moisture? Whether the material is fully dried. So this is achieved with the help of a microcontroller called Arduino with the GSM module is there. We also placed a load sensor. Through the load sensors, the data will be, the weightless information will go to the Arduino. Arduino with the help of GSM module will send a SMS to the mobile. So you can see a screenshot of a mobile where when you are keeping a material for drying now, it will show that the material is kept for drying and we are supposed to place 100 grams of sample in the tray, weight load sensor tray. So at the set interval, you can set it half an hour or 1 hour or even 2 minutes. You will get what is the weight of the sample, present weight, or what is the weight loss from the previous to now second value. Also, it will tell you what is the present moisture content. So also once sufficient moisture content is reached, it will tell that the material is completely dried. You can switch off the dryer. So this has been already copyrighted, this particular software work. So I again don't want to go about the advantages as I already mentioned. In addition to these dryers and the gadgets, we also develop small scale machineries for the fishers. Those are small scale farmers. Of course, we are not doing for the seafood industries. They are far ahead and they do use imported machineries. Our intervention, indigenous interventions, meant for small scale fishers like the fisherwomen who are in the fishing system, like they are selling fish or they are in the fish market selling fish. When you go to a fish market, the major the DDS job is removing the scales of the fishes. So we have a descaling machine. It is basically a hand operated descaling machine. About 5 kg of fish can be loaded in the descaler. So you can see that there is a latch, you can open it and put the material. Not, of course, 5 kg, about 3 to 4 kg fish can be loaded there. And with that handle, slowly the handle has to be rotated. Once you slowly started rotating, the fish will get a friction, the aberration with the drum, because the drum inside is a perforated mesh is attached. So when the fish is moving with the drum and falling back, there is a friction happens between the fish and the drum, then the scales are removed. Here the only limitation of this particular machine is it is meant for small fishes having size less than 250 grams. Then we do have a machine with motorized version, similar setup, but only attached with a motor. Here about 10 kg of fish can be accommodated, total volume. About 5 to 7 kg of fish can be loaded here. So here the drum speed has been already attached, like it has been fixed. Whereas in the hand operated machine, if you have to slowly rotate, about 20 rotations per minute. If you are rotating very fastly, no descaling will occur because the fish will co-rotate with the drum. So there won't be any friction or any gravitational force will not work. So this machine has to be fine-tuned by the user. As and when they start working, they know what speed it has to be operated. Then we do have a variable speed descaling machine with a water spray system, similar setup. We also have a mini fish descaling machine which can be kept in a kitchen. All the parts are detachable. The earlier two versions, the issue is cleaning is one of the important issue. Here, all parts can be detachable and cleaned. Then another aspect is refrigerated fish vending kiosk. These actually it is meant for selling the fresh fish in a hygienic condition. It's like a hygienic way of handling and selling the fish. And also you can see the fishes are being sold by the fishermen in the roadsides. The photograph shows. Just below that you see this type of kiosk will be used so that the fish will be kept in a hygienic way. No ice has to be used, and we do have a refrigeration setup here because the power supply is required and the normal refrigeration system will maintain the temperature required. So this type of refrigerated fish vending kiosks have been given subsidized and given to different parts of the country, especially the Fisheries Department. Government of Kerala has shown an interest, and about more than 20 members of this kiosk were sent to different fishermen groups for demonstration purposes. Here, the advantages are no odor, no flies, no contamination. Fish will be displayed under the chilled conditions, about 0 to 4 degrees Celsius. The fish vending kiosk is attached with a fish descaling machine and a cutting table where the fish can be cleaned and cut. Then it can be given to the consumer. And we do have a provision to put the ice box. And this unit is actually a mobile unit, and we do have a plan to attach with the solar system, and it has to be ready. Weight, in terms of weight, it has to be reduced so that it can be used as a pull cart, and the fisherwoman can take to the markets. In addition to the government of Kerala, we do have a CSR funding from Cochin Shipyard Private Limited, a shipbuilding company here at Cochin. They have also invested about 20 lakhs for this project, and then about 25 refrigerated fish vending kiosks were given to different parts of the country for the fishermen groups. You can also see this is our plan. We are intended to have a solar attached system in years to come. We do have fish meat bone separator to remove the meat from the bones. Actually, when we have any value-added product to be prepared, we should have a mince. So to get that mince, we should have a bone separator. So the bone and flesh has to be separated. Here it is basically a drum and belt mechanism. A drum will be there. A belt will go closely and tightly attached to the drum. So the fish will be introduced between the drum and the belt. The drum is already a perforated drum. When you drop the fish, the belt will press the fish against the drum. So since the drum is having the small openings, perforations, the flesh will go into it, and that will be separately scrapped and taken out. We do have a mini fish meal plant here. And there are a lot of electronic gadgets, especially these gadgets were developed not now, it was developed about 30 years back, 30, 40 years back, in fact, 1980s, 90s it was developed, where those days the electronic gadgets were just started blooming. So those days scientists at CAFT at the engineering section have developed different gadgets like navigation light control system for the fishing vessels, rheometers to find out the braking strength, multi-channel freezer temperature monitors, alarm systems, salinity temperature depth meters for the fishing vessels when they are going for fishing, multi-channel temperature monitor, fishing logs, water activity meter and all were developed here. Then there are some small projects developed also here for some students projects, where there is a Peltier cooler device also developed using Peltier module. Then we also majorly work on developing a container for live fish transportation. You know, the material sent in the live condition, especially the freshwater fishes, which is going in a live condition, fetches more price. For example, about 10 hours of travel, you are sending a fish in a live condition, it should be in the live condition. The mortality rate should be very less. So for that, CAP has taken an initiative and we have developed a fish transportation container, live fish transportation container, which has the double jacketed cooling system. The temperature of the water will be reduced to less than 20 degrees Celsius. We do have a aerators, filtration systems, so that the temperature of the water will be reduced to less than 20 degrees Celsius. Aeration will be maintained. The fish stocks density also can be maintained. And the survival rate was about 75% to 90%. About 10 to 20% mortality is there, of course. And we are also now working, this was not the latest one, about 3-4 years back we developed. Now we are developing a waterless transportation system, hyperbaric transportation system. Now we are also working on a bulk transportation system. A truck full of fish will be sent from one place to another place. Then we also developed a solar powered aqua feed dispensing system in the aquaculture ponds for feed dispensing. Generally, it is done in one corner of the pond. So here we have developed a system with paddle wheels. The feeder will go inside and we have developed a remote control system here. So from sitting outside, this machine can go inside the pond and spread the material, the feeds, wherever it has to be spread, that can be done. So such system also we have developed. Then as I already told you, in addition to this, we also work on non-destructive techniques for assessing the fish quality and freshness. So one such work was on, this is also not a very recent one, 3 years back. Now there are a lot of advancements we are doing and that I will tell you. This freshness sensor, we are trying to take it from the color changes in the fish. You can see the variations in the color. Of course, from naked eye, you can't see from day 1 to day 2 what are the changes. But when you do with a machine vision system, it can be very well identified. What is the minor changes which is occurring in the fish, especially in the fish eye. So based on that, we have done a pixel count analysis through which we can identify whether the fish is fresh or not. That was correlated with the lab analysis. Now you can see also a 3D printed compact machine here, mentioned A and B, where the fish has to be kept in a tray and sent inside. Then you can press capture the image and then the image will be converted into pixel count and then it will correlate with your lab analysis and say whether it is fresh or not. We also have developing on a mobile application now of late. The fish has to be selected and immediately it will correlate with the pixel count and give you the results. As I already mentioned, we also work on energy and water use optimization techniques for the seafood industries. If we go to a seafood industry, the big seafood industries, their per month electricity charges in the tune of about 20 lakhs to 40 lakhs. And if you know the maximum energy load, which goes for air conditioning, refrigeration and air conditioning purposes, including general lighting. And the most of the energy goes to the compressor portion. So what we have done under this particular activity, we made a real-time monitoring system. Smart energy meters were fixed to the seafood industry's equipments. It is not stopping with energy auditing, it is one step ahead, energy management, in fact. So smart energy meters attached to the cloud. We do have a hardware software system at institute level through which each equipment, its working condition, working nature, the amount of energy it consumes, everything can be seen on the real-time basis. Provided the type of material being handled at the industry, its capacity is loaded in the system, which we have already given a permission to do that. We will be getting a information on the type of the energy consumption. For example, specific energy consumption. 1 kg of product to be prepared. What is the energy consumed, or how much the carbon footprint has gone? For example, you see this particular picture. We will come to know how much kilowatt hour, that is the electricity unit per production on a set interval. You can set an interval and we can get it. Then this is a photograph showing how the smart energy meters were integrated with the electrical lines, water lines. This is also for water flow meters with solenoid valve were implemented. And we made a very pertinent suggestions to the industries how the energy can be saved. Energy savings can be done from modifying our form based on our suggestions. In addition, there are general suggestions like if the equipment is very old, it's not that much efficient, that has to be replaced. The laborers or the workers who are working they have to be imparted training or the awareness on what is the energy, how the energy is important, how that is affecting the overall efficiency of the system, and all awareness to be created to the people. Underutilization of equipments. For example, an equipment meant for 100 kg of fish, a air blast freezer located in a seafood industry, 1,000 kg of material can be loaded, but the operators have used only 100 kg of fish and run the system. So you actually not utilized it. It's underutilization. So these are all the things where we can make a change. So there are a couple of suggestions, recommendations to the industries. And also, in addition to that, we also developed a alert system so that on a real-time basis, the manager or the user at the industry level will get as and when anything goes wrong. For example, now all the units are connected with smart energy meters, and we have already developed a system. If anything goes wrong, based on their historical energy usage data, if anything higher or lower, there will be an alarm system. We will go to the manager. So he comes to know that there is something wrong. He can check it and then rectify that. Another area is the future refrigeration system. That is, now the refrigeration systems, either in the seafood industry and the domestic market, the refrigerants are being used are HFCs, that is hydrochlorofluorocarbons, which is to be phased out as per our Government of India initiative. That has to be phased out, which is depleting the ozone layer. So now the industry is going for natural refrigerants, clean green refrigerants. For example, ammonia, liquid nitrogen, carbon dioxide. So here I am talking about CO2, carbon dioxide, which is already available on the ambient. You can use that CO2 and then you can throw it to the ambient again. Whereas other refrigerants, you cannot leave it to the ambient. It has to be treated and left to the ambient condition. Here CO2, there is no problem. CO2 is abundantly available. Take it, use it, and then throw it. Here, we do have a collaboration from Indo-Norway project where IIT Madras is associated, Indian Institute of Science Bangalore is there, Bitsplan also there, CAFT also there in this, where two of our seafood industries at the Kochi region have implemented this CO2 based systems. So which is clean, green, and then we do have a CO2 refrigeration educational training unit at CAFT for demonstration purpose. Now, these are all about the technologies. Now, I would like to present how these technologies are going to the field. So, we have a very big incubation center at CAFT, that is Agri-Business Incubation Center, ABI, where all these technologies are listed there. We have an incubation facility. So, for example, the dryers. Somebody comes for incubation of drying system or the drying business. So they will visit. You can see the client will visit here. All the dryers and its preparations will be shown to them. They will get registered as an incubator. They will be trained prior to getting incubation. For example, hygienic dry fish production technology. That is the thing they have come here. We will train them for 3 days. How hygienically the dry fish has to be prepared using our machineries. During the incubation time, we will provide them detailed project reports, economic analysis, pilot plant facility will be allowed for them, dryer can be seen, networking, regulatory requirements like FSI and all, they used to take a license. What are their requirements for the products? Any finance loan to be taken, test marketing, everything will be dealt in the Agribusiness Incubation Center. We do have agencies who are empaneled for supply and installation of these drying machineries. For example, tomorrow, one dryer to be installed at Rajasthan. So how we will do it? You send a mail to us saying that, see, this is the thing, this material to be dried, and I am interested in this much capacity of dryer. So we will get this information and contact a manufacturing agency, empaneled agencies, that you quote the item for this particular unit. The design is ours. The quote has been already received in a sealed cover by CAFT. We know the quote. Only we want to know what is the transportation and installation charges. That quote will be forwarded to the party. The party will pay upon money to the industry, that manufacturing agency. So they will pay about 5% royalty out of that to the institute. So this is how this commercialization works. Then they can use our dryer also. The dryers available at CAFT also for 6 months to 1 year. So during that time, they can use our FSA license, CAFT logo, go for test marketing. We have a fish processing division here. I forgot to mention, we have got 6 divisions, 1 engineering section. We have a very good fish processing division where we have a section for packaging, we have a section for byproduct utilization, we have a section for fish processing. So there, what type of packaging material to be used for this, how the material has to be cleaned, pre-processed, everything will be dealt in the training program by the experts from that particular section. We do provide them detailed project report, DPR, so that they can give it to the banks or some agencies to get the loan. These are some of the installations in different parts of the country. One is commercial model hybrid solar dryer with the LPG backup at NEH Impal, about 250 kg installed condition, working condition. Another one is at Kerala here, 250 kg. Another one is at Siva, and that is Central Institute for Women in Agriculture, Bhubaneswar, about 60 kg dryer. Then 10 walk-in type solar tunnel dryers at Odisha, coastal areas for the fishermen groups. These are some of the success stories, technologies, photographs. You can just have a look, different types of machines. So through these agencies only, we are reaching out to the people, not only dryers, it includes refrigerator, fish vending kiosk, descaling machines, some other equipments from the CAFT. And some photographs of training programs. Some photographs showing inauguration of dryers. Some dry fish products were launched by Honorable then DG ICR. Some of the photographs showing the dryers. Commercialization of other technology like refrigerator, fish vending kiosk, handed over to a group, fisherman group. Some of the media cuttings showing that the technologies in the field, especially the refrigerated fish vending kiosks, are given to the resorts, the retail fish vending shops for hygienic selling. And as I shown you in some slides, we are going to bring up a lighter version of that kiosk, which can be used by the fishermen on the roadsides. These are some of the other photographs. And we do conduct regular training programs for our own people. Also, we take training from other countries, especially African continent. We have conducted so many training programs under different names called ITech, ARDO. In the ARDO training program, we had a trainee from African country, and he was here for about a week. So he was very much interested with our descaling machine. You can see the photograph on the right side top, where he was very much impressed with this, and he went back to his lab and then he fabricated that. And then he told that it is very much useful for them, and he sent a photograph as well. So these are some of the achievements. And you can also see the dry fish shops, a modern dry fish shop where all dry fishes are kept. Again, photographs of training programs, our consultancy services, again media cuttings, media cuttings. These are the dry fish brands launched by incubation from CAFD. You can see different, more than 45 incubators have registered here. More than 15 dry fish brands were launched to the market. And you can see all the packages will have a logo of CAFT as well as ICR. And during the test marketing time, they will use CAFT FSSAI license. After once they go out and start their own business, they will be taking their own license. Okay, that's all about this particular presentation. I took about 45 minutes now. If any doubts, queries, any discussion is there, we can have it now.
Thank you, sir, for this very informative session. And now participants can ask questions to clear their doubts.
I could see that 44 participants are there. Anybody, any doubts, any queries?
I think there is no questions.
By the way, you have not mentioned, madam, what is the background of the participants?
They are from Fisheries and Veterinary Science.
Okay. They are basically working officials or?
They are working officials.
Okay. Okay, then if no queries, thank you so much for giving me this opportunity.
I would like
And
to thank
I thank all the participants for being, I don't know whether being attentive, rather being attending this particular session. Thank you so much.
Okay, thank you, sir. Thank you, sir. Now this session has come to an end. Thank you, participants, for your patient listening.